algebra, we are continuing through the binder with CO2. Talking about estimating the root of a non-perfect square. We talked about non-perfect squares with rational and irrational numbers because what type of number is every non-perfect square? Rational or irrational? You go. Irrational, whereas every perfect square is considered rational. So we're going to start by defining, what is a root? We talk about square roots. What is that? What is a root? Not the easiest definition to come up with, but Emily? Okay. Something that when multiplied by itself equals another total. Something along those lines there. Anything else? Okay, so let's just start with an example, right? If we have the root of 49, the square root of 49, what is the square root of 49? 7. Why? Because 7 squared, right? Or 7 times itself, 7 times 7 equals 49. So in one sense, a root, we can call it the opposite of an exponent, right? That's why we include the R in the order of operations, because when you undo square rooting something, you would square it. If we square 7, we're back to 49, right? If we square 7 to get 49, we get back 7 by taking the square root. So a root is the opposite of an exponent, and it is when you have a number multiplied by itself. A number multiplied by itself. Okay? And a perfect square is a number with integer roots, which are rational. Right? 49 is a perfect square because its roots are integers, 7, and therefore root 49 is a rational number. A non-perfect square is a number with decimal roots, which would be irrational. The root of 13. Nothing times itself is 13. No rational number by itself times itself is 13, so it's going to be an irrational value. Okay? So this table that we're going to fill out here, it's going to list all your perfect squares. This can be written on a help sheet because it's under the Wise Old Owl section. You will not be able to use a calculator on this section of the test. Okay? So putting this table on a help sheet might be very valuable for you. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. All right. So starting with the perfect square, 1 is actually a perfect square. What is the root of 1? 1. Okay. Next perfect square is 4. What is the root of 4? 2. Next perfect square is 9. The root of 9 is 3. What's the next one? 16. The root being 4. What comes after that? 25. The root of 25 is 5. Then 36. The root of 36 is 6. Then 49. The root of 49 is 7. Then 64, which is 8. I heard someone say 81. The root of 81 is 9. 100. Root of 100 is 10. 121. Root of that is 11. 144. That's 12. Then this one runs right by our school. It's the highway. 169, which is 13. Then What's 14 squared?
196.
196. And lastly, 15 squared? 225. Yes, they do go on forever, right? But the ones that you should probably commit to memory, 1 through 15 are used fairly often in geometry, especially with right triangles and things like that. So it's worth it knowing these, but you can put it on a help sheet for this test if you would like to. Okay? Everyone got that down?
Yeah.
Good? And so our goal today, right, if I ask you for the root of 81, you know that's 9, right? You've worked with that before. But if I ask you for the root of 95, a non-perfect square, our goal today is to be able to use what we know to estimate that value, right? Just near as 10. We know it's an irrational number. We know the decimal goes on forever, but can we come up with kind of like a general estimation of what that value is? So let's start with that. What did I say? 95. Okay. The root of 95. We know it's not a perfect square, but how can we use the perfect squares to come up with a pretty accurate value? Here you go. What do you think?
Well, it'll be in between 9 and 10.
And how do you know it'll be between 9 and 10?
Because perfect squares are 81 and then 100, and
Right.
95 is in between that.
Yeah, we know that 95, the root 95 is in between the root of 81 and the root of 100, right? Why is that important? Because the root of 81, we know what that is. Exactly, it's exactly 9. We know the root of 100 is exactly 10. So now, if we've got those two whole numbers, those two integers to kind of work with here, is root 95 going to be closer to 9 or closer to 10? And how do you know that? Yeah, 95 is closer to 100 than it is to 81. Therefore, we know that if you think about kind of this number line between 9 and 10, it's going to be on that side of 9.5, right? Right in the middle here, 9.5, halfway between 9 and 10. We know it's going to be on the 10 side, or closer to 10. Okay? So, I'd accept 9.6. I'd accept 9.7. I'd accept 9.8. I'd accept 9.9, right? It's just an estimate, okay? I would not accept 9.5 because that's you telling me that this is right in the middle of 81 and 100, which it isn't, okay? Likely, it's probably more in like the 9.7, 9.8 range, and that's where you can use a calculator to check your answer. However, on a test, because it is an estimation, I would accept either of those 4 answers.
So when we level, when we still check it and put in the right answer?
You're not going to be able to use a calculator on this part of the test.
Check your answer with the 5, use it again.
Right. Yeah. If you write down 9.6 and your calculator says 9.8, that's okay. Right? You're in the ballpark. It is just an estimation. But if you put 9.3 and your calculator says 9.8, then you would want to fix that because you're on the wrong side of half. Okay. Christopher, give me a number between let's go 50 and 225. 101. Estimate for me the root of 101. Our first step is to figure out, well, what two perfect squares is 101 between? Chance.
100 and 121, but you can also write below as 100 or as 10 and 11.
Right. We know that the root of 101 has to be between 10 and 11 because it's between root 100, which is 10, and root 121, which is 11. Okay? So if you think about all the numbers between 10 and 11, here's 10.5 right in the middle. Okay? Which side of 10.5 will it be on here? Yeah, James.
That side. So right.
Yeah, the right side?
No, left.
Yeah, okay. It'll be over here, right? Because 101's super close to 100. Okay, it's going to be on this side of 10.5. So really, I mean, it's 10.1. If you put 10.2, fine. I mean, it's obviously not going to be 10.3 or 10.4, but at least you're on the right side of half. I'll give you credit, but it is 10.1. Okay? Questions on this? All right. Luca, 15 to 225. Not close to 95 or 100. And 1.
15 and 225.
Yeah. Sure.
220.
220. Okay. The root of 220. What two perfect squares is the root of 220 between? James?
15 and 14. 225 and 196.
Yeah, so root 196 and root 225, which you said 14 and 15. And it's important we know what those perfect squares are because that gives us actual, integer values to work with here. And so you think about all the numbers between 14 and 15, with 14.5 being smack dab in the middle, which side of 14.5 is it going to be on? Priya?
Right side.
The right side. Because 220 is closer to 225, it's going to be closer to 15. Okay? Now, 220 is only 5 away from 225, but it's 24 away from 196. Okay? So this is probably going to be like a 14.8, 14.9 situation, but I would also accept 14.7. 14.6 is stretching it because that would tell me that it's just a little bit beyond half, but it is much closer to 225 than it is to 196. However, being an estimation, I would accept it. You're on the correct side of 0.5. Questions on this? We good? All right. So you do need to show your work, okay? This is the work that I need to see here. You don't have to write all 4 answers. You can only need to write 1, okay? But I do need to see you writing the 2 perfect squares that are on either side of the value that I provide. And then what are those integer values beneath them, okay? At the very least, show me that you're doing this, right? So I want you to work with those perfect squares. I want you to be comfortable working with roots because we're going to work with them a lot. Okay, so it's important to know what they are and how to use them. As you flip through the assignment, you've got 8 of them here. Does this negative sign out in front change anything?
No.
Not really. It just means that your answer is going to be a negative, right? You want to do one?
Sure.
Sure. Let's do negative 160. So negative 160, we're still going to look at those perfect squares on either side of it, root 144 and root 169, which we know is 12 and 13. So again, thinking of all those numbers between 12 and 13, 12.5 being in the middle, which side is it going to be closer to? Closer to 13 or closer to 12? 13, right? Because negative 160 or 160 is closer to 169, therefore it's going to be closer to 13. So we have our same 4 answers that I would have accepted before: 12.6, 12.7, 12.8, 12.9, but because the original value had a negative sign, all of these would just have to be made negative. Negative 12.6, negative 12.7, negative 12.8. Negative 12.9. So the sign really doesn't change anything as far as the process. You just have to make sure that you make your answer negative when you get that sign. Okay. So these 8 to do, I think that's a 2-pager today, is it not?
No.
It is. Oh, you're lucky. So more to do on the backside. And then I have you work backwards. It says write the value of each decimal using a square root. An example would be if I gave you 7.1, that'd be about the root of 50. Why? Then we're working backwards here, right? If I give you 7.1 and I ask you, how would you write that value as a root? Why would 7.1 be about the root of 50? Priya?
Because
that 7 is a root of 49 and it's only 1 off.
Yeah, we know that the root of 49 equals 7, but we're just beyond that. We're 7.1. We're a little bit past 7. We know that root 64 is 8, right? So we're somewhere between root 49 and root 64, only being a little bit past 7. That's probably going to be root 50. Would I accept root 51? Yes. Would I accept root 52? Yes. Would I accept root 63? No, because that's like 7.9. Okay, so it's working backwards, going from the decimal to the original root. James, yeah.
I think I'm 2 ups of the first page.
You have double the first page?
Yeah.
Do you have the second page?
Yeah.
Oh. Great.
What should I do with this page?
Recycle it.
Do it.
Yeah.
Yeah.
Use it to doodle.
Okay.
So let's do 14.3. Okay. And again, working backwards here, 14.3 is between 14 and 15. How would you write 14 as a square root? What is the square root equivalent of 14? Say it, Chance.
196.
Root 196. What is the square root equivalent of 15? 225. So we know that 14.3 being somewhere between 196 and 225. What would you estimate? Root 190. Are you saying that because this is 0.3 away and that's 3 away from 196? Okay. That's not a bad method to use. You do have to be careful though. Like if this was 14.7, you wouldn't do that because it's closer. It'd have to be closer to 225 than it would be to 196. So, but root 1 at 99, I would accept that. It's probably more in like the low 200s range, right? Up to 203 possibly. I would not accept the root of 220 because that's too close to 225, right? That's beyond the halfway point there. So halfway between 196 and 225 is what? See, that 29 comes apart, so about 14, so about 210. Okay, 210 is the halfway point between 196 and 225, so it has to be less than the root of 210. All right, but that working backwards piece there. Question or just stretching? Okay. Now, when will I ever use this? Why do I care? When will I ever have to possibly estimate a square root? Remember these little globes are like real world application. Through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot of land to be a square, that's convenient, with an area of 200 square miles. The length and the width of the plot, however, have faded. Don't know what the length and the width are. Approximately how many miles long and wide is the plot of land? Well, if we know that the area of the square is 200, how would we have found the area of a square? What do we do to find the area of a square? Length times width, right? But because it's a square, what do we know about the length and the width? Sorry? They're the same, right? So in pre-algebra, algebra beyond, did you last year refer to length and width as base and height? No? Okay. So in pre-algebra, we're going to start to do that. Length and width kind of die out. And the base of a figure is the horizontal side. The height, I got you. The height of the figure is the vertical. So for a rectangle, this would be the base and the height. Okay. Same thing as length and width, but it's called something else. For a square, whatever the base is, the height will be the same. Right? If the base is 5, the height's 5 for a square. If the base is 10, the height's 10. So if we're going to take base times height to get that 200, but we know that the height is the same as the base times the base will be 200. What do we know about b times b? What's another way to write that?
B squared.
B squared. Something times itself, right? And so if we want to figure out what b is, we want to solve for the length and width, the base and the height of this square. How do we take an equation like b squared equals 200 and undo an exponent? Think of perm dots, those opposite operations. What undoes an exponent? Hugo.
You find the square root of both sides.
Yeah, you root, right? A root undoes a power. If we root both sides here, the root of b squared, those operations cancel out. Just like division undoes multiplication, addition undoes subtraction, a square root undoes squaring. And so we're left with b by itself, and lo and behold, here we are finding the root of a non-perfect square. Isn't that fantastic? So, now you're doing exactly what you did on the rest of the page. You're finding the root of a non-perfect square, right? What two perfect squares are on either side of root 200? Break it down, okay? You have another word problem after that. A square bulletin board has an area of 80 feet squared. Estimate the perimeter of the bulletin board. So same situation. Thank goodness it's a square. But you've got the square with an area of 80, right? You essentially need to find the root of 80 to figure out what a side length is, and then find the perimeter of that bulletin board. A backyard in the shape of a square is 34 feet of fencing surrounding it. What is the area of the yard? So here you have your square backyard here. The perimeter is 34. It's a square, so all four sides have to be the same, right? But the perimeter is 34. What is the area of the yard? And then, is that it? Yes. And then we talk about cube roots. We'll actually talk about this tomorrow after we talk about the homework. So don't worry about this. It's not homework. But if you want to try it, you can, but we'll talk about it. So, yeah, just finish CO2 up through those three happy globes. And there you go. Questions, comments, concerns, complaints, columns, congratulations, or criticisms? You have about 7 minutes to work on it.
That's the difference between last year and this year. You don't have as much time to work on stuff.
Yeah, so math class last year was an hour. This year it's 45 minutes. Mrs. Gambino had the opportunity to kind of go into the next class also if you need more time, right? Because math was back to back with religion. And so, but this, I gotta let you go at 9:15 whether I want to or not. So, yeah, you'll probably find yourself doing a little more math work at home this year than last year. But that's how it goes. Jonas.
What happened to Mr. Olson?
Mr. Olson?
Yeah.
He decided to leave teaching altogether and kind of start his own company. He is a handyman at heart. He loves doing side projects, remodeling projects, things like that. So he always said he spent about a decade teaching, and he taught for 13 years. So, but yeah, he's doing side handyman projects for hire. I asked him if he could help me with my garage door, and he said that I couldn't afford him. So, oh well. That's what friends are for. Anything else? All right. Remember the outro? That is how you math.
Like and subscribe.
No. It's don't forget to like and subscribe. We'll try it again. That's how you math.
Don't forget to like and subscribe.